Alright, young people, so last video, which may have been today or may have been yesterday, we talked about the dot product and how to find it, okay? And we mentioned that whenever you have a dot product of 0, that is super special. Alright, and today we're going to kind of talk about why, which is angles, okay? So here's your formula for the angle between vectors. So you have some, wow, that was terrible arting. There's a vector, call it V. There's a vector, call it W. And this angle between it, theta, we can find using this formula. So cosine of the angle between the vectors equals the dot product of the vectors. Dot product over, this is the magnitudes multiplied, right? So mags multiplied. Alright. So that's what our formula is, and you'll have to use your calculator because you got to do that cosine inverse stuff. Okay, and so we'll do that here in a second. Also, don't forget how to find the magnitude. It's just your Pythagorean theorem. If it's 2D, then you use the regular old Pythagorean theorem, square root of the two components squared, added up. If it's in 3 dimensions, you use the super Pythagorean theorem, which is adding up all the squares of the components, x, y, z, and then square rooting that number. Okay, this is what we did on those activities last week. Alright, that stuff will not go away. So now let's go ahead and try to find an angle. The angle between vector P and Q. So, we're going to start it off by saying that cosine of theta, well actually, yeah, I'll go ahead and do that. Cosine of theta equals the dot product of P and Q over the magnitude of P times the magnitude of Q. So let's go ahead and start finding all of this stuff. Let's first find the dot product. So the dot product of P and Q is going to be 7 times 2, that's 14. Negative 4 times 4, that's negative 16. And 3 times negative 6, negative 18. So boom, add it all up. That's negative 20. Oh my goodness. I think that's literally the same one I had on the other side. And I just copied it. Good stuff. Okay. One thing you can notice is that on the other side, the way that I wrote it was I wrote plus negative 16, and over here I just wrote minus. That's just me being lazy. It don't matter. It doesn't really make much of a difference. It's kind of your preference. Okay. Alright. So the dot product is negative 20. Got that. Let's go ahead and find the magnitude of each of these. So let's start off with the magnitude of P. That is going to be the square root of 7 squared plus negative 14. Negative 4 squared. Remember, nobody cares about the negatives, and I don't trust you to put it in the calculator correctly. So for magnitude, don't even worry about it. Don't even bother. Okay, because you're going to mess it up. Likely mess it up. Alright, magnitude of Q, square root, same thing, 2 squared plus 4 squared plus 6 squared. Okay, now I've got to put all this stuff in the calculator. So I did not prepare, and I did not have the calculator pulled up. So I'm going to do that here in a second, and then we'll type in these numbers. And here we go. Let's go ahead and figure out what is 7 squared plus 4 squared plus 3 squared. Get that beautiful number, but don't forget we have to square root it. Now some of y'all might do this all in one step. That's cool. That's cute. That's fine. Okay. But you don't have to. So I'm actually just to not round. I'm gonna go ahead and write square root of 74. Okay, because I'm gonna be a cool kid right here. Alright, let's go ahead and do the other one. Okay, but remember, this decimal answer is fine as well. Okay, I'm just leaving the square root of 74 because I don't feel like rounding. Same thing, 2 squared plus 4 squared plus 6 squared. Boom, did it, done. Square root of 56. Alright. And again, I can find the decimal answer if I really wanted to, but since I'm putting this all in the calculator, I'm just going to leave it like this. Okay, so now I've got all of it. I've got the dot product, I've got each of these magnitudes, I'm ready. Okay, I can substitute here. Okay, so I'm going to be like, oh man, cosine of theta is equal to negative 20 over the square root of 74 times the square root of 56. Okay, and then you're going to stare at it. You'll be like, alright, so what do? I just plug that in the calculator, and then I get a number. It's going to be disgusting. You're going to be like, okay, let me see what I get here. Oh man, my mode is off. I'm tripping. Okay, let's change this to degrees. Bam. Alright. So you're going to be like, alright, cool. Let me put that in the calculator. Negative 20 divided by, oh man, I didn't even make a fraction. There we go. Divided by the square root of 74 times, times the square root of 56. And that's cute, okay? But that's definitely not your angle. Your angle is like a little baby. Nah, it's not the baby. So what we're going to do is, remember, whenever we're looking for an angle, we actually want to do cosine inverse. We're looking for the angle, so we're going to do cosine inverse. So trig cosine inverse. And then we're going to put all this in there to get the angle. Since I already put it in the calculator, I'm going to go ahead and cheat. I'm just going to use answer. So control answer. There's the bell. Oh my gosh. What am I going to do? And there's my angle. Good stuff. Good stuff. Good stuff. Good stuff. Okay. Last note is that if it's 0, if the dot product is 0, you get 0 for the whole thing. When is cosine 0? For what angle is cosine 0? Oh my gosh, think of your unit circle. When is cosine 0? That's up here. That means that if you ever get dot product of 0, your angles are perpendicular. Perpendicular. Also known as orthogonal. If dot product equals 0. Alright, good times.